Hey everyone, this is Steve. I'm glad you're here. Let's say we draw a parabola from this quadratic together. All right, let's start ripping it apart. Got a negative sign in front of the x squared, which is actually a -1. Important thing is that that's a negative number in front of the x squared, so our parabola is going to open down. And just like every other quadratic and parabola out there, we're going to have a domain -infinity to infinity. All right, that was the quick part. Now we got to find the vertex. This will take a little bit of work. To find the vertex, when we're in this form, we have to use this -b/2a formula. So I've got -2 over 2 times -1, which is actually going to be -2 over -2, or just 1. Please remember that's not the vertex, that's just the x value of the vertex. You want the entire vertex, you got to take this x value and plug it back into the function. So you do g of 1, which is going to look like this. That actually crunches out pretty quickly to give you a -1, which is just the y value of the vertex. You want the entire vertex, you got to put those together in an ordered pair. So our vertex is going to be 1, -1. Okay, now that we have our vertex, we can also come up with our axis of symmetry. Don't let the axis of symmetry spook you, everyone. Axis of symmetry is always a vertical line. So it's just going to be x equals, and it's going to be the same x value that you use in the vertex. So in this case, x equals 1. Done. Now, the range for this one can also be found right now because we have both of our vertex and the direction our parabola opens. So check this out, everyone. My range is going to go down to -infinity because this parabola opens down, but the highest it will ever get is the y value of the vertex, which is -1. Now this is interesting, everyone, because what you will notice is that the range never goes above the x-axis. The range is just negative numbers. So it would appear that when we graph this parabola, it will only be below the x-axis, which means it really shouldn't have any x-intercepts. So what does that mean if it doesn't have any x-intercepts? Well, if we have no x-intercepts, that means our zeros are imaginary. And I'm going to verify that right now. Check it out. So we've got this thing in the quadratic formula called the discriminant. And it's just the part b squared minus 4ac. And it can actually tell you if your zeros are imaginary by whether it's negative or positive. So check it out. B is going to be 2, A is going to be -1, and C is going to be -2. So if we use our discriminant here, we're going to have 2 squared minus 4 times -1 times -2, which is going to be 4. 3 negatives, so there's 1 left over, -8 equals -4. What that means, everyone, since we get a negative number here, is that our zeros are imaginary. So we have no x-intercepts for this graph. All right, so that might cause us a little bit of trouble, because right now all I have is the vertex. Well, I can still get a y-intercept. We can still get a y-intercept. So the y-intercept is found by plugging a 0 into the function. And if you plug a 0 into the function, it actually zeroes out the first 2 terms and leaves you with a -2 at the end. So our y-intercept is going to be 0, -2. Well, just a vertex and a y-intercept doesn't seem like too much to go on, but we'll do our best. So using this limited information we have, let's try and draw a graph. Okay, so here's our grid. Let's see what we got here. We've got a vertex at 1, -1. All right, we have a y-intercept at 0, -2. That's not a whole lot to go on. I do have this to my advantage. The axis of symmetry does give me another point because the y-intercept has to have its mirror image on the other side. So we do get the y-intercept's mirror image over there. So let's just label these. Our vertex was at 1, -1. Our y-intercept was at 0, -2. And thanks to the axis of symmetry, we get another ordered pair at 2, -2. Well, we probably could draw a sketch just using this, but let's give ourselves a little bit more information. So let's go a little bit farther away from our axis of symmetry and our vertex and plug both a 3 and a -1 into our original function. So if you plug a 3 and a -1 into the original function and crunch out an answer, both of these actually end up being -5. So everyone, you got to plug the 3 and the -1 into this original equation up here, and then you should be able to get those two -5s. All right, that's going to help a little bit because we get 2 extra ordered pairs here. 1, 2, 3, 4, 5. So we get another point right there. We get another point right there. That will help me draw a slightly better graph. Nice clean cup. Nice clean cup. And you will observe our graph never touched the x-axis. So that means we have no x-intercepts, which means our zeros are imaginary. And if you want to check for yourself later, everyone, the zeros for this sucker actually end up being 1 plus I and 1 minus I. You can check that with the quadratic formula or by completing the square. All right, I hope that helped. Thanks for watching.